Welcome to Sir RP's channel. In this video, you're going to learn how to illustrate angles of depression. Are you ready to learn? Sit back, relax, and get ready to learn. Let's first define angle of depression. It is the angle between the horizontal axis and the line of sight to the object when the observer looks downward. Take note, when the observer looks downward. So from there, when the observer is here, then this is the line of sight. He looks downward, and this is the horizontal axis. Note, then the angle formed there is what we call the angle of depression. Let's have examples. Number one, the angle of depression from a lamppost to a point in the ground is 60 degrees. How long is the light beam to the nearest whole number if the lamppost is 10 meters high? Let's have the step-by-step solution. First is to illustrate the problem, letting x as the length of the light beam. We have here the angle of depression, and then we're looking for the length of the light beam. From there, just observe the illustration. The problem can be solved in two ways. One, the right triangle can be constructed as shown. It is clear that the horizontal line makes a right angle with the lamppost, hence 30 degrees is used because it is the complementary angle of 60 degrees. The first solution is to have a triangle here. And by that, it's very clear that this forms a right angle. Therefore, the complementary of 60 is 30. So from there, we can use this triangle here to find the value of x. That is the first solution. Let's have the answer. In this case, the sides with respect to 30 degrees are the adjacent side and the hypotenuse. So we will use the cosine ratio. Again, cosine, it's ka, the ratio of adjacent over the hypotenuse. This is 10 meters, which is adjacent to 30, and x is the hypotenuse since it's opposite to the right angle. Let's have now the solution. Cosine 30 is equal to 10 over x. We'll get the cross product. Multiply 30, multiply cosine 30 and x, that is x cosine 30, and 10 times 1 is 10. From there, to find the value of x, divide both sides by cosine 30 degrees. Then we'll now have our value, which is approximately 11 and 5/7. Thus, the length of the beam of the post is approximately 12 meters. So this is approximately 12 meters. That is the first solution. What is the second one? You can have this. Another way of solving this problem is recalling the properties of transversals to parallel lines. Let's illustrate the problem with a different triangle. Notice that the upper and the lower horizontal lines are parallel cut by transversal line x, making the angle of depression and the angle of the elevation congruent since they are alternate interior angles. Again, recall the concept of transversal lines and the alternate interior angles. Given this is 60, the angle of depression, right? So this is 60. So since we have a transversal line x here, okay, by the property of alternate interior angles, we can say that the angle of depression, which is 60, is just equal to the angle of elevation, which is also 60. Okay, so that's the second way of solving the problem. So from here, with respect to 60 degrees, 10 meters is the opposite, while x is still the hypotenuse. So opposite and hypotenuse will be using the sine ratio. From there, we'll get the same answer, which is approximately 12 meters. The decision is up to you whether you're going to use the first or the second solution. Okay, that's for the first example. Second, Anthony is standing on top of a hill and spots a house in the adjacent valley at an angle of depression of 12 degrees. The base of the hill to Anthony's line of sight is 60 meters high. How far is the house from the base of the hill? First, illustrate the problem. So we have here, let x be the distance of the house from the base of the hill. You have 60 and 12. Again, there are two ways to solve. Given this relative to 12, the opposite side is just as long as the height from the base of the hill to Anthony's eye. The distance from the house to the base of the hill is equal to the length of the side adjacent to 12 degrees. Thus, the tangent ratio must be used. So from here, tangent 12 is equal to 60 over x. Okay? Why? Because again, this is using the second solution. Okay? The opposite over adjacent. This is 12 degrees, taking the alternate interior angle. So 60 is opposite while x is the adjacent side. The answer is approximately 282.277 meters. Therefore, the house is 282.277 meters away from the base of the hill. Okay? Using the second solution that I presented earlier. Other questions? If none, let's have the individual practice. 1. The top of the Bantayan Lighthouse is 127 meters above sea level. The angle of depression from the top of the lighthouse to the approaching ship is 32 degrees. What is the distance of the ship from the foot of the lighthouse? 2. An office worker in Makati from her office window sights a jolly jeep about 53 feet from the base of the building. If the height of the office worker from the ground is 45 feet, at what angle of depression does she see the jolly jeep? Okay, so for your answers, please use the comment section. And hey, we have here a key point. Again, the angle of depression, it's the angle between the horizontal axis and the line of sight to the object when the observer looks downward. And that ends our session for today. Thank you, Quipper Philippines, for the slides used in this presentation. Once again, thank you and happy learning. Don't forget to subscribe and click the notification button to receive updates. This is Sir RP.